So this is Thinking with Math Models Investigation 2 and the additional practice problems. And this is problem number 20b, and we're dealing with an inequality. And we want to solve the inequality and then just understand what the values are that we get. So really, initially, you just kind of ignore the sign in the middle. Just think of it as an equal sign, and I'm going to solve this like algebraically like I would any system where I have two equations and trying to solve for x. We actually want to find out what this x equals. And to do that, we have to get all the x's on one side and all the numbers on the other side. So to do that, I'm going to add 1 to both sides, which when you're solving these problems, you want to do the same thing to both sides of the equation, and then things will work out just fine. So 8x, and then that becomes 0. Negative 1 and a positive 1 is 0, so I'm not going to write anything down because there's no reason to write down a 0. And then over here I have 4x plus 8. 7 plus 1 is 8. So I've just put the 8 there. Now I'm going to subtract 4x from both sides. So I have that. And I did that because I want to not have any x's over here. So that's why I subtracted that. So 8x minus 4x is 4x. And it's less than or equal to, now that went away, which is good. And then I'm left with an 8 plus 8. And so I'm just going to write down the 8. And I'm getting closer now. So now I have 4 times x is less than or equal to 8. And so if I divide both sides by 4, 4 divided by 4 is 1. 1 times x is x. And it says x is less than or equal to 8 divided by 4, 8 fourths. Again, it's a fraction, but we can reduce it, or we can divide. 8 divided by 4 is equal to 2. And so now there's the solution I was looking for. X is less than or equal to 2. So that means numbers that are less than or equal to 2 would make this true. So like 2, 1, 0, everything that's equal to or less than 2 in this case would work and make this equation true. And that's how you solve an inequality. You just think of this sign. It doesn't really change anything. It's just telling me that there's more than one value that will make this a correct answer. Lots of values. Everything that's less than or equal to 2 would make this problem true. And we could actually go back and check by putting those numbers into the original equations, 2 or less, and we'd see that it comes out to be true.